I want to thank everybody for coming today. It's a nice turnout. What I'm going to talk about today is just sort of a background very quickly on insecticide resistance. Why? Because you're going to hear a little bit about managing fungicides in the next talk. And I wanted just to point out we can't forget about insecticide resistance. While there may not be a problem right now, it's got to be on the tops of our minds, at least in the back of our minds, if we're going to be doing it. So we would like to avoid it. So I'm just going to really quickly go through. I will try and make this as quick as I can. What is it? How's it developed? Implications, its responsibilities to manage, the role of IPM in resistance management, and resistance management and the role of IPM. Now, before we get started, I'd like to get a little information about you. So I handed out a little, what looks like a little clicker. It's a, it looks almost like a calculator. Does everybody have one? If you don't, raise your hand, and we'll get some out to you. This is called audience response system, and so you can look at this question and answer, you know, how do you describe yourself? 1 would be farmer, 2 would be PCA, 3 would be other. So that's just the way that I can get some kind of demographic background as to who's here today. How do you primarily describe yourself? And just let you know, these clickers are absolutely useless except for this in the room. It won't change your stations at home. It won't open your garage. And if you walk outside, it will blow up and leave a piece. $30 a piece, I gotta watch it. And I've been very good. I've done this thing, I don't know, 40, maybe 40 times now. I haven't lost one that I got. So go ahead and, hang on a second. There's something wrong here. We may not be able to, hey, it's on. No, you guys are fine. Let me just take a second here to, you know, I might have to do something different. Just give me 1 second. It looks like I'm going to want to close out just for a second. And I want to make sure that I brought it up in the right program. I thought I did, but apparently it doesn't look like it's doing that. And I'll just bring mine up directly. I apologize, but there is some interaction here that I would like everybody to take part in. Okay, now the polling's open there, so now you can see we can start responding. There we go. So what I'll be watching here is the number of responses that are coming across. If we kind of stop there, we'll kind of levels off. I'll go ahead and push the next button, and we'll see what the response is, and we'll go through this. What I've done in this one is to ask some questions about what your perceptions are about insecticide resistance management. Maybe we can use that as a place where we can start a discussion. Okay, it looks like about 32, so I'm going to go ahead and stop it there. So it looks like we've got 50% farmers, 38% PCAs, and 13% who came for the cold room. A question here, have you participated in the San Joaquin Sustainable Farming Program and the Sustainable Cotton Program? Just for my own information, I was curious to see. Have you been enrolled? Have you worked with somebody who's been involved in it? Have you been involved in it as a PCA, working with a client who's been involved in it? That kind of a thing. Or if you've just been assigned to the board, possibly. Okay. We have some familiarity. That's good. Okay. So started sort of thinking about insecticide resistance. This is not something new. This publication was published in 1933, and it's entitled, "Are We Developing Strains of Codling Moth Resistance to Arsenic?" I didn't think you could get resistance to arsenic, but apparently you can, and the bugs are beginning to do it. So this is not a new problem. As you can see from this graph, we continually develop resistance as products and classes of products are brought out. Currently, as of 1990, there was about 470 or 500 AIs that had a insecticide resistance problem associated with it. So this is a problem that's ongoing. while it may not be in our face right now, it's something that is always on the edge lurking, and we need to be aware of. So what's resistance? It's the ability of an insect to survive an insecticide treatment at a rate that other members of that population could not survive. It's an inherited characteristic that can be passed on to the next generation, so it's a strong selection pressure. Some folks might call it, I'm not getting quite the control I used to get. I'm seeing some field failures or words I've heard. Sometimes that can be resistance. Sometimes that can be maybe an application problem, if you're not getting the coverage you need, etc. So just because it's not quite getting the control that you might be accustomed to, it might be beginning resistance, or it could be just a problem that can be taken care of in application. So how do insects develop resistance? It's as everything in nature, it's a selection pressure. The insects don't necessarily, they have something within them already that if put pressure on can utilize that characteristic to detoxify a pesticide, for example. If the pressure's not there to use that particular genetic background, then it just sits there quietly in the background. But as soon as something comes in and requires them to sort of give them a selective advantage, if you will, that they're able to detoxify something, then of course they're going to give more offspring, that genetic trait's going to be moving on, and therefore we start to see an increase. So it's really, quite honestly, the survival of the fittest. It's just a new, strong selection pressure on a population. So you might have one resistant individual, that particular application selects out, allows more of those to survive, and within a few generations, potentially, you have a lot more of the resistant critters. Now, within insects, if you're turning a population around in weeks or versus months, or in fungus with diseases where you might be turning around in days, the more generations you have, the more pressure you have, the more that selection pressure is going to be operating. So basically, you select out those that are resistant to whatever it is you're doing or spraying, and eventually you end up with a population that you've changed the composition. So what are some of the mechanisms of resistance? You can do, most common is metabolic. The insect, particularly aphids, as one colleague of mine described them, they're nothing but a sack of enzymes, and there's a bunch of enzymes there, and maybe you have a certain one that can detoxify an insecticide. So if you can get an enzyme that detoxifies the insecticide or binds to that poison, a protein that binds to the poison that can then be excreted, you've got a way around that particular poison. You can get resistance to the target site, so that instead of a particular neural pathway, it might slightly change or have the ability to change if the pressure was put on and selected for it, so you can reduce or avoid the poisoning. And then finally, there's one called behavioral, where the insect avoids poison through change in habits. And mites are one example of that, where they apparently could be able to tell where the droplets were and they could sort of move around it. Another example is with mosquitoes that hover as opposed to landing on the water. Those that hover avoid the poison that was placed on top of the water, and so you're then selecting that particular behavior. The insect doesn't know that it's avoiding a problem. It's just doing what it's doing, and it's getting an advantage over the other guys. So there's these are the major ways that you can get a mechanism of resistance in insects. But insecticides act on specific targets. There's specific modes of action. If there's anything to take from this presentation to remember today, is MOA, modes of action. We can affect their growth and development. We can affect their respiration. We can affect nerves and muscles. And with BT and Lepidopterus, or caterpillars in particular, BT works on the midgut to split the midgut and actually cause toxic poisoning like that. So the key to resistance management are MOAs, or modes of action. So these are the various ways that we actually affect insects and manage increase their mortality. There's a group out there called the Insecticide Resistance Action Committee, or IRAC, not to be confused with Iraq. And it's a consortium to improve communication about insecticides and how they work on insects. It's mostly crop protection companies that have come together to share information so that together they can work in getting better education about insecticide resistance management, as well as information among themselves to see, to help the overall longevity of products. They developed a classification or grouping according to the mode of action. And we'll spend some time talking about that. So you assign a class or a group number to that mode of action, and all new insecticides fall into an existing group, or a new group might be created. It wasn't more than 20 years ago, we probably had maybe a dozen or less of modes of action. Now we have close to 30. This has been just an absolutely golden age of insecticide chemistry in terms of finding new ways of getting in and affecting the metabolism and physiology and the development of insects. I think somewhere over here I've got a chart that shows this. Don't expect anybody to see this at all, but this is just the kind of thing IRAC looks at. I mean, go to their website. It's a fabulous website. And you can download these kinds of things. You can ask and order charts for this kind of a thing. But I just wanted to point out that there's a lot of different mode of actions. There are different categories. And some of the more common ones there are carbamates at 1A, organophosphates at 1B, pyrethroids are a 3 group, nicotinoids are a 4. That's just a number they assign to it. But it's important as we go along because you know that nicotinoids have a particular mode of action that's different from the way the pyrethroids affect an insect. And so it's two entirely different selection pressures. So here's a question for you. There will always be new technologies to manage pests. We lose a product, we've got something else coming on. Do you strongly agree with that or strongly disagree with that? The question is basically, you know, I mean, I was told by somebody recently that, well, you know, why should I manage the miticides in almonds? After all, they're just going to come up with new products at some point, so let's use the ones we got when they're gone. That was a statement and a sort of a philosophical approach to pest management. So you're right. There are always going to be new technologies to manage pests, but who is primarily responsible for managing insecticide resistance in your opinion? Is the manufacturer primarily responsible, the farmer, the PCA, the Department of Pesticide Regulation, or all of the above? All of the above, people say. Okay, good. That's a point I'm going to be making too, is that's all our responsibilities. Here's a question. Product price determined by insecticide choice, not resistance management.
Oh, that's positive. Some of my growers. Since I have no say, I'm going to go neutral.
That's why they put neutral there.
Yeah, that's a good one.
Okay. I don't have resistant bugs, so I don't worry about it. I'm putting these in partially because it does allow us to go in some interaction, but it also allows us to express our opinions. And these are important points I would like to be making. And this, I hope this kind of gets us thinking in that way. That I mean, I understand why you would think this way, and there may not be anything wrong with that. Okay, so a lot of people here believe that they strongly disagree that I don't have to worry about it as soon as I don't have it. Okay, that brings us to this famous fellow here, who's not running for political office, by the way. But the concept of what me worry, I don't have a problem. Why should I worry about it? And the points I'd like to make is that insecticide resistance, as we talked about, is everybody's problem. It's not just in your field, it's just not in your area, it's just not in your pest. And it costs money to development of new products. Let me talk right there. So just because new technologies might come along, doesn't necessarily mean we shouldn't be fostering and conserving those products we have for as long as we can. Because eventually, as we all know, and we've seen this really in the last 10 years, is that a lot of these products come back as lower cost generics as they go off a patent. And so if those things are there for a longer period of time, then of course lower cost for the same products we've been using. So we'd like to keep them around as long as possible, so that we can take advantage of competitive marketplaces once the patent is released. So those are reasons why it's important to be continually vigilant. Okay. Which of these three would you consider to be the best rotational program for resistance management program? And we're rotating products because we want to go around these MOIs. So For example, MOI1 is one particular active ingredient. MOA2, mode of action 2 is another, and MOA3 is another. So these are all three different kinds of modes of actions on a particular pest. And so is using the same mode of action through 3 generations versus modifying with 3 modes of action versus 1 mode of action, well, 2 modes of action of the same type in the 2nd generation versus the 3rd generation. Which do you think would be the best approach to managing? And we'll talk a little bit about this later. So up there, it looks like people are picking number 2, which, in my humble opinion, is what I would have put down as the correct answer, that I'm rotating between these 3 different modes of action. Across generations, we're reducing the amount of selection pressure on any particular genetic background. And that's kind of what's recommended. Here's an example of that from the pest management guidelines we did in cotton some years ago on beetle armyworm and cotton, showing all the available products we were suggesting for the management of it, the mode of action classification number we talked about here, and then when to, suggested areas of when to apply. And in this particular case, we're moving things around so that no product is used twice in a row. And in this particular case, we're looking at integrated pest management saying, let's go with the most selective product at the beginning of the season and going to less selective at the end of the season, so we don't really get everything messed up in the early part of the season. Let's go with the most selective first, and then put in some of the more broad spectrum later on if we need it. So you can see in this particular case, we're mixing and matching different kinds of modes of action, and you'll notice within certain groups, like Intrepid and Diamond, they're both insect growth regulators, but one's a class 18, one's a class 15. I'll talk a little bit more about that in a second. Okay, resistance can develop to any insecticide class. Oh no, pardon me, resistance can develop only to an individual insecticide class. That is to say, if you're resistant to organophosphates, that's all you're going to be resistant to. So once you get into a class, that's it, you just change products, everything will be out the door, or you find something else. So you strongly agree that in fact it's only to an individual class, or you strongly disagree with that statement? Okay. So basically people strongly either disagree or strongly disagree, and that's good because it's these things called cross resistance. It's where it's a gene that promotes resistance to one insecticide which functions on another unrelated insecticide. The example that really came up was almost a 20-year gap between the use of DDT and the other organochlorines when pyrethroids came out. It turns out that mode of action was so similar that the resistance of the enzymes immediately kicked back in when pyrethroids came in under particularly mosquito control, etc. Carbamates and organophosphates are under different subgroups, but they can influence each other as another example. Now this cross-resistance, where a previous insecticide endows resistance some years into the future, is different from multiple resistance, which are different genes within a population acting on different modes of action. So you have multiple resistance to a number of compounds within a population. Okay, resistance can be avoided by rotating products. I'm going to get into a little bit about rotation. We've already kind of led to that as an earlier question. Okay, so it's talking to the choir to some extent, but I want to point something out. It's products versus MOAs. It's important to rotate mode of action or IRAC category classes. A mode of action group is a class of insecticides that contain many products. I remember some years ago we were fighting whitefly. I talked to people and said, I am rotating. I'm going from Warrior to Asana. I'm going from Capture to another pyrethroid. And so, just for an example, group 3A is pyrethroids, and there's a number of products there. Same thing with group 4A, the neonicotinoids. There's a number of products there. And so just because you combine or you're changing products, isn't necessarily meaning you're changing the mode of action. Then you go into these combination products that have become a little bit more popular by the manufacturers over the last decade or so, where you're combining, like leverage, where you're bringing in two particular products, a pyrethroid and neonicotinoid together. So those all have to be kind of watched very carefully. Now this is the point I'm trying to make as well. I talked about resistance within a pest. Well, we control pests, but we treat fields and orchards. Kind of get what I'm saying here? We're treating for navel orange worm or for PTB in an orchard, but there's also mites in that orchard, there's diseases in the orchard, there's other worms in the orchard. So you have, say, 3 pests in the system, and you're focusing on doing a good job of resistance management with this particular pest. So you're only using this thing in the first generation, another generation comes in, and then you apply, even though it's the same mode of action, it's 2 generations apart. So that's not a bad approach to management. But pest 2, you say, oh, well, I've got these 2 pests at the same time, so I'll put in this mode of action as well to get this guy. And then, oh, wait a minute, I need it, and I'll put in a third over on this guy. And then pest 3, you're treating for something because you're going to mix those 2 products perhaps in the tank. And then pest 3 again. So you see in the same time frame as you're focusing maybe on an individual pest, but thinking about managing several pests in the orchard, you can end up with a situation here. So if this now becomes just the orchard, the 3 pests, you can see what you've done is you've actually put on modes of actions across, if you will, through the entire season and then back to back over here. So it's one of those things that, you know, try as we may, we sometimes just kind of lose sight of the fact that I'm thinking about ligas and cotton right now, but now I've got worms, so I've got to control worms. But I might have used a pyrethroid just 2 weeks ago for ligas, and now I'm using it for worms. So any ligas that's left out there is going to be getting that additional pressure. Tracking insecticide use by IRAC categories is too much trouble. I've just described it to you. You strongly agree or disagree with that statement? I mean, my God, how am I going to do this? Or this is easy to do. My PCA takes care of it, right? Sure. I love it. So where do I find my mode of action categories? Okay, so I want to track it. Where do I find it? The UCIPM Pest Management Guidelines. In our guidelines, where we talk about products that are suggested for an IPM program, that's one of the pieces of information that's there. Most labels, and I put the question mark there, will have it. Labels now are a lot easier to find online with such sites as Agrarian and CEMS, and then the IRAC website also has it. But with a lot of the, you know, it's not a requirement to have it on the label, so some companies put it, others don't. And I know this is a really crappy image, but you can find it usually here. What it is, it's white, gray, white. And so this is the group, the number, which happens to be 18 for Intrepid, and the insecticide. So some labels have it, some don't. We'll find it. So if we have a particular product or a class of products on our particular guideline, we'll put that number there. And this is an example of that. This is for alfalfa, the alfalfa caterpillar, and Intrepid's there, and there's the number. So it's a mode of action number. We have it for fungicides. We also have it for herbicides, by the way. These same schemes are set up with herbicides and fungicides. Now here's something we hear that, my gosh, I can't throw this thing with a brick anymore. Resistant insects are just stronger. You know, there's something about them now. We've created a super bug. What do you think about that statement? Strongly agree or disagree? I hear people say this, particularly trying to manage ants. Kind of all over the map. That's good. Any genetic change comes with a price. Why was that particular mutation the insect had in the background until that pressure was put onto it? It wasn't very useful, and maybe it comes with what's called a fitness cost. So that, okay, I can detoxify this particular insecticide, but what it cost me was I'm a little slower, or I'm a little weaker in some way. So if you remove that pressure that's been selecting out that individual for that particular genetic component, Then the other insects now that maybe are stronger because they don't have that particular weakness will come back in and replace the population. So it's not necessarily that insect is better equipped to handle nature, it's just better equipped to handle that particular application of insecticide we put on. So I'm going to get into now sort of the final parts of this. IPM has a limited role in managing resistance. Strongly agree or disagree with that statement? Okay. Very good. I was thinking backwards myself and saying, no, you guys are just really putting your thinking caps on today. So yeah, in fact, most people disagree in fact with that statement. IPM does have a role. Where does it have a role? It has a role in when you're even scouting and monitoring what's out there in the first place. Not only the pests you might be interested in, but what other organisms, including the other pests, might be out there. How many are there? Using the action thresholds, the population level threatening the crop. So I don't treat unnecessarily. I don't apply that selection pressure unless I absolutely need to. But I think here's the key of what I leave you with today is using cultural control, physical control, biological control, anything else right now, in addition to chemical control, anything you can do to increase that mortality, it puts new selection pressure on the bugs. So for an example, I mentioned that the fitness cost. Maybe the thing just isn't. Maybe it's not as reproductively capable as the regular insects. Maybe it's a little slower, so a predator can get it, or something along. Or maybe it's more susceptible to disease. I don't know. But anything you can do that can pick off another bug, you can remove that source of resistance from the population, and so you kind of keep the population, if you will, on its toes. So cultural control, perhaps with the way you do an early harvest, or whether you wait for you do it an earlier harvest, or you're doing some kind of selection of a resistant variety. That's another pressure besides your chemical control. Same thing with biological control. And then with chemical control, let's use selective chemistry as much as we can so we can maintain our biological control as much as possible, and of course rotate it across your modes of action categories. And as I said earlier, it's an advantage because we can use some of these products for future use as generics in our programs. And of course, the increased cost of developing new products if we wear the other ones out. So, IPM does play a major role, and resistance management plays a major role in IPM. And I just point this out as the selectivity this is kind of a food web in a cotton field. If you're going for ligas, you end up getting pretty much everything else there out of the picture as well. So all of those things are actually adding to the ligas, the ligas mortality factor. All those things are additional selection pressures on it. And finally, I'd just like to mention that, as I usually do, I like to think in the large scale. Resistance occurs right down here. It presents itself in the population. If we don't manage it in our fields, pretty soon it's a community problem, and the next thing you know, it's a regional problem. If everybody's doing pretty much, particularly you've got a large landscape, say corn, soybeans, and everybody's doing the same thing at the same time, you're really putting a lot of pressure on it. So from a standpoint of the organism, all the way out to where we're trying to manage in our farms and fields, resistance management plays through that entire continuum of ecological scales. Just an aside, to some extent, if you're looking at insecticide resistance management, IPM at the landscape scale, one of the things that has been suggested is creating untreated refugia or safe zones. So in this case here, as I understand this diagram, this is a field without a refugia, and these are resistant beetles. So you spray them and just select out for the resistant beetles, and pretty soon you got a lot of resistant beetles. Because all they can do is mate with themselves. Whereas if you have a little bit of refugia here, which means you didn't spray that part of the field, you do get some continually mixing in going on, and you get fewer and fewer, fewer of those. Natural enemies also provides a sanctuary for natural enemies and pollinators, which is important these days. Within a field or between crops, these kinds of landscape things can be done. Strip crops and alfalfa, vegetative strips, hedgerows are examples of places where things can be laid out. If in our situation, some people may be treating a problem and there's not a problem in the next field, well, that acts as a refugia because they can go back and forth and exchange their genes as well. So I think we're in a much more advantageous position here with the diversity of crops we have. We're not horizon to horizon with a single crop, everybody pretty much acting the same way. We've got all sorts of crops intermixed and the bugs are moving throughout them, and I think that's helping us provide some refusion. Okay, final couple of questions. Having multiple mortality factors can help slow resistance and insecticide resistance. True or false? And if you don't get these right, you've got to turn that sheet back in over here. Kidding. All right. The following are good insecticide resistance management practices: tracking MOAs, rotation between MOAs, treat only when required, or all of the above. All right. I should have asked this question first. I might have saved you 25 minutes. When thinking about insecticide resistance management, only my field, orchard, and pests should be considered. Or maybe not. Okay. All right, thanks a lot for your time, and I appreciate it. Again, what the good news about this presentation is, we don't have to worry about a particular insect that we're worrying about right now, and instead if we just think about how we can do better insecticide resistance management, we may never be getting there. So, Sarah, quick question?
I've recently gone to some chemical company meetings when they're putting out new products, and they'll say, this product over here we've got resistance to. Our new product is in the same group, but it's got this chemical chain here that makes it different, therefore there won't be any crop resistance. Is that hooky or what?
My understanding is if it's in the same category, 3A, it's to say it's a 3A. Now, they may say they've got some stuff over here, but I mean, as close as that comes is with organophosphates and carbamates. They both have the same mode of action, but slightly different. So actually working between those, it'll put a little pressure on it, but not the same pressure. But if you're putting on the same 3A compounds of neonicotinoids, as far as I understand all the rules that they talk about, it's you know, but it does, but it also may be a 3B. It's a neonicotinoid, but that is a completely different story.
So I noticed you didn't mention the rates of the...
Right. Right. The IRAC, and I've got a list of their recommendations over here on a piece of paper, by the way. They recommend label rates. That's one of the first things they say is use the label rates. Don't play around with going higher, going low, because it does two different things on it. You know, you can either really put on high selection pressure early with a heavy load. If you go light, then you begin to kind of get them a little sick, and you already begin to select those out. So they just say label rates is about the best way to do it.
The argument against low rates always seemed to me that it suggested that the low rates are causing some kind of genetic change that increases resistance. I never quite thought that was quite straight thinking.
Well, one of the things we find is the same sort of argument, and I think it works, is with taking antibiotics, low rates of antibiotics constantly, or just constantly putting antibacterial stuff around. That sort of thing does tend to, with a low rate of antibiotics, it tends to select out the things that it might be a recessive gene, and you're getting a few more recessives together, and then you really get into trouble when you need it. So I'm not quite sure about the population gene flow and dynamics of the whole thing, but I do know basically they say there's pros and cons, there's advantages and disadvantages on both sides of the extreme, and just go with the middle because that's what the manufacturers have said. So, okay, I'm going to give it back to Marcia while I change there for the next speaker.